Hey guys, Travis Gillespie here. Today we're looking at surface area. In this first example, we're asked to find the surface area of each prism. And below, you're going to see a rectangular prism. And we already know how to find area. Let's just do a brain refresher real quick. If I'm talking about the rectangle along the front side of this shape, I just want to highlight it real quick so we can see it stand out just a little bit better. How could we find the area of this shape? Well, it's a rectangle, so we know that the area of a rectangle, well, it's capital A, is equivalent to length times width. Okay, so I would take the value 12, that represents the length, and multiply it by the value 2, which represents the width in this case. That would give us the value of the area just of that one individual shape. But there are multiple shapes along this object, and I want to know the area not only of each shape, I want to know the area of each shape added together. If I find the area of each shape added together in this figure, well, I'll find the surface area. And that's what surface area is asking us to do. How much surface does the entire area cover? That's what we're really asking in these problems. So what I want to do is erase this information. In prior videos, you've seen me break up, or maybe even if you're in a class lesson of mine, we've looked at nets and how we can use nets to solve these problems, how we can break up a 3D image or a 3D object or shape or figure, how we can break it up into simple flat surface shapes. So a good definition for nets that I've used in the past, it's a Mr. G definition, so if you want a good one, you'll have to look in a dictionary, but the one I like to do is just imagine this unfolding. Well, if it were to unfold and lay flat on the floor, you would have an object that it is a flat surfaced object. So I'm just going to write flat surface here. It is a two-dimensional object figure, or it's a two-dimensional shape, so 2D shapes. And if we were to take all of these 2D shapes at the very end and fold them back together, then they would end up creating this 3D figure, shape, or object here. So they fold, I'm going to make that note, they fold into, and I'm using a black pen. Let's go back to that blue pen real quick. They fold up into the 3D shape you're dealing with. Okay, so that's what a net is. I'm not going to draw nets in this video. You can look at some of my other ones, or look through the textbook if you're wanting to get a good idea of how you can draw nets for each individual shape. Okay, what I'm going to do here is show you the Mr. G method of how I like to find the surface area of 3D objects. So what I need to do is make sure we have plenty of room. I'm just going to move this screen over. All right, and the first thing I'm going to make a note of is how many different shapes I have. And I have plenty of different rectangles, but some of them are congruent to one another. Some of them are the same size, same shape, they're identical to one another. And they are parallel to one another. So what I'm going to do is I'm going to highlight the ones that are congruent to one another right now. Right now I have one base shape that's highlighted here, and I have one base shape, and it's called a base shape, but it's also on top. So I'm going to go ahead and highlight that as well. So I have a rectangle on bottom that is congruent to a rectangle on top. So right now I know I'm going to make my note that I have two rectangles that are congruent to one another. So two rectangles that are congruent, and I am going to go ahead and just draw those rectangles on my screen. From there, what I want to do is make a note of their dimensions. Well, I know it has a length of 12 inches and a width of 5 inches. So it is 12 and 5. And let's fix that 1 real quick. And actually, I'll just rewrite the entire thing. So 12, there we are. And now I want to erase these highlighted pieces of information. If you don't want to use highlighters, then what you can do is use values or symbols such as the value 1, or maybe a check mark for the base shapes, and then change those values and shapes as you move along through the figure and break it up into simple parts. So let's go ahead and erase this information. I'm going to highlight the next two sides that we see are parallel and congruent to one another. It's this side wall here. So I'm going to highlight this side wall, and I see that the side wall along the left is parallel and congruent to the side wall along the right. So we can highlight that as well. So I know that I have two additional rectangles. I'm just going to write that down again. Two rectangles. And these two are congruent to one another. So what I'm going to do is draw my next two shapes, or next two rectangles, and they don't have to look the same as the other rectangles that I've drawn. In fact, it might even be better if they do look a little bit different, so that when I go to do the math, I can tell them apart. So now I want to make sure that I note the dimensions of this shape. Well, the dimensions of this rectangle, they're kind of separated or broken up a bit. I'm going to use a yellow highlighter just to note. I have one of the dimensions is the width of the rectangle, and it's 5 inches. I'm just going to write the 5 below here. Now let's grab that yellow highlighter again. There are no other values along the side of this rectangle, so I have to look to the other one, or the one that's parallel to it, and I'll find the dimensions of the missing side. It's the width, or the height, of the rectangle, and it happens to be 2 inches. So let's go ahead and make a note that the width here is 2 inches. Okay, and now let's go ahead and erase all of this information here. So here we are, cool stuff. And I want to make a note that there are 2 additional rectangles that are congruent. So I'm just going to make that note. I'm going to highlight those last 2 rectangles. One is along the front wall here. And this is actually the first rectangle that I highlighted at the beginning, but there's also an additional one that's parallel to it along the back wall. So this last rectangle. And the dimensions of these 2 rectangles are 12 by 2. So let's draw this rectangle. I know the length is 12, the width, or the height, is 2. And let's erase this information. Now how can I use all of this information to find the surface area? Well, again, it all falls back to that formula, the area of each individual shape. So in this case, for each rectangle, I'm going to use the formula, length times width. Well, let's go ahead and write that down real quick. The length here is 12, so I'm going to take 12 and multiply it by the width, which is 5. Okay, so if I find the area of this shape, and then I double it, so I'm going to multiply by 2 here essentially, then I found the area of both base shapes. If I do this math for the next 2 shapes, then I should be able to add everything together to find the surface area, which is what I'm going to do. So let's repeat this method over here. The length times the width times 2. And we'll double this information because I have 2 rectangles that appear that happen to be congruent. And then I'll find the area of this rectangle, which is 12 times 2. And I'm going to double that information because I have 2 rectangles that are congruent. So all I have to do here is find the area of each individual shape, double the area for each individual shape, and then what I'm going to do at the very end is go ahead and add all of that information together. I'm going to do one last thing. I'm going to put brackets around this information here, around this information here, and around this information here. Notice how the brackets are separating each individual problem up before I add. I want to make sure that I find the area of both shapes here before I add it to any of this other information. And I want to do the same for this problem, or these 2 rectangles, and the same for these 2 rectangles. Find the area of each individual rectangle before you add the information together. So let's just work within the parentheses first. I have 12 times 5, which gives me a value of 60. I want to just change back to my black pen real quick. So I have 60, and then I'm going to multiply 2 times 60. Then we'll add that information to, well, 5 times 2 is 10. We have to multiply that by 2 or double it. And also, 12 times 2 is 24. And we'll double this information. I'm still going to keep the brackets for now. So let's go ahead and back down here. I'm going to draw my brackets in. Cool stuff. I'm going to go back to the black pen. 2 times 60 is 120, plus 2 times 10, which is 20, plus 2 times 24, which is 48. Well, 120 plus 20 is 140, and we're going to add that to 48. Let's go ahead and get just a little bit more room on the screen. Now 140 plus 48 will give us a value of 188. Now I'm not done. If I want full credit, I need to make note that I've found the surface area. So rather than writing a capital A here, I'm going to write capital S is equal to. I want to fix that S real quick. So capital S is equivalent to 188. Our units are in inches. So inches, don't forget your dot for the N, inches squared since it's area. So the surface area of this entire rectangular prism is 188 inches squared. Cool stuff. I'll see you in another problem, guys.